Our recording is in progress. Hi, everyone. Good afternoon. Thanks for joining us. My name is Julie Bills. I am a product marketing manager here at Petuum, and we're going to share a conversation with you today about supercharging MLOps. So I'll introduce you to our lead product manager, Adil Islam, who will give you a little bit of an introduction before we hear from our CEO and Director of Engineering. Adil?
Thank you. Thank you, Julie. So very excited to be having this talk with everyone. And as Julie mentioned, Aurick and Tong are going to be actually going a lot deeper into MLOps. And you'll also see a demo of our product, keeping in mind that Petuum is entering into a private beta. We'll talk more about that later. If you want to apply, if you're interested, maybe you came here because you've seen what we're doing, want to learn more, it's a great time to be here. Do let us know. At all times, the chat open. Please do send in your questions in Q&A as well. So I just want to give you a quick intro to what Petuum is. Our mission is to unlock human productivity and well-being by automating and scaling AI ML operations. So our goal is to scale ML ops. And I believe through this talk, you'll also learn a lot more about how exactly we do that. And if it's interesting to you, do reach out. The team at MLOps, just so you know a bit more about the company that you're hearing from, we were founded by Aurick Qiao and CMU, and in fact, there's a community of CMU, Stanford, and Berkeley folks here at Petuum. We've been around for some time. In a startup phase, we've been working with a large number of advisors and have some partnerships across the board, across the world, really. And we are entering into the point where we'll be accepting some private betas based on the usability, based on the ability for our customer to actually benefit from our platform, and also based on the use case. We're trying to be very exclusive about that. So you'll be talking today to Aurick and Tong. So be sure to have your questions. Both have a lot of experience in machine learning and AI, as well as of course building our product. Before we get into this, I just want to make sure that everyone here in our audience is really thinking about ML ops in a way that would make sense from our way of supercharging it. The main question to think of is, are you in a role associated with ML ops? You could be a machine learning engineer, you could be a data scientist, you could be a data engineer, you could be a software developer, you could even be a product manager for machine learning products. Right? The core aspect of ML ops, as we see it, is on the one edge of data operations and on the other edge of software development and AI applications, and bordered by everything associated with the IT infrastructure space. So MLOps sits at this core creation, deployment, governing space. And some of the things that we are always looking at is how well do people think about infrastructure orchestration, how much do they think about training, ensembling, managing all of the different MLOps categories, and how they all work together, because synergy is the key to having an effective MLOps system in your organization. So something to think about, right? Do you belong in the MLOps role? Do you see yourself in here? Do you see any things here that really catch your eye and make you think that's something that I want to really advance in my organization? Let us know in the chat. Do ask us questions at any time. And speaking more about our about getting in touch with us, asking us questions, and this is a final little pitch for me. We are hiring a lot of different roles. So if you're interested, give us a look. Come to petuum.com or go straight to Greenhouse. We've got a lot of stuff going on social as well. Give us a connect again, especially if you think that this is a technology that you're very interested in trying out. But all right, without further ado, I'll hand off to Aurick, who is going to talk to us about supercharging MLOps. And do join us in the chat. Let us know what pain points you're facing, what MLOps means to you, and if there's any ways in which your team has worked with MLOps. So thank you. Aurick, over to you.
All right, yeah, thanks, Adil, and thanks everyone for coming. Like Adil said, this will be a little bit of a preview of our talk coming up at ODSC East, which is actually tomorrow. And also just a fair warning to everyone, we're currently still working on finishing up these slides. So please, if anything's not clear during the talk, just put your questions into the Q&A. We'll try to answer them as timely as we can. So we'll be going over a couple of topics today. So just a brief description of the current state of MLOps, what it's like out there in the wild, our approach to solving some of these problems in MLOps with what we were calling full stack composability. And also we'll be including a little bit of a sneak peek video demo at our closed beta product. Okay, so give me a second. All right, so one of the most notable trends in AI machine learning today is that applications are becoming increasingly more diverse and more complex. So here's just a example of a question answering system that we built at Petuum, and these are the different parts of the system, and something like this by today's standards would be considered relatively simple as far as AI machine learning applications go. But even if we just look at this application and only look at like this core AI logic section of it, it already exhibits a very high degree of compositionality across several different steps and sub-steps of processing. Right. So for example, when we get an input from the user, we might want to, process that input to understand what the query is. We then might want to find the relevant passages from a large corpus of text, then to re-rank those passages in terms of their relevance, extract those answers and aggregate them into a final answer, and then to refine the final answer by applying something like style transfer or bias reduction. And when we're finally ready to enter this MLOps stage of continuously maintaining, monitoring, and improving the application in production, we're finding that like this core AI logic is just a very thin slice of the overall operational lifecycle of what we need to maintain. And what we find is that, we find ourselves bringing in new tools and frameworks to support just like bits and pieces of the overall MLOps needs. For example, like data annotation, model retraining, model evaluation, and deployment and monitoring. And what we end up with is many different moving parts at multiple layers of the whole machine learning stack. From the mathematical steps of the core AI logic to each stage of the continuous MLOps lifecycle. And all of this have to work seamlessly with each other from end to end in order to ensure a successful outcome for our application. And at the same time, there's an increasingly proliferous and fragmented ecosystem of tools which are all aiming to support the AI machine learning lifecycle. So this chart here just shows a very thin slice of that ecosystem. And even this thin slice already has hundreds of tools supporting, each supporting a part of the AI application, from data annotation or modeling techniques, or different training algorithms to different distributed systems for deployment and monitoring. And, for our question answering system, we had to take bits and pieces from this ecosystem that were best suited for our applications, stitch them together by writing a bunch of custom glue code in order for this end-to-end to really work. But a different team who's working on a different AI application might see completely different needs than what we saw with our application, and thereby stitch together completely different set of tools and frameworks than what we did, right? And yet another team might make a different set of choices than either of the two teams altogether. So just summarizing, where MLOps is today is, everyone needs to write a lot of, custom glue code and resulting in unclear boundaries. And that results in a very customized craft production type of operationalizing machine learning. And, this fragmented ecosystem and writing all this glue code causes a lot of the common issues that we hear in the MLOps world, such as, it's very difficult to maintain your machine learning applications, and it's very hard to upgrade them once they are in deployment. There are gaps in end-to-end observability and automation between all the different steps crossing all of the different systems that we need to stitch together. And it also results in an ineffective utilization of team expertise. A really common symptom that we hear a lot is, data scientists having to struggle every day with infrastructure instead of the tasks that they want to do and are very good at. And all of this results in a really difficult to scale AI application and business due to the operational friction that all of these issues introduce to the organization. So with that said, where we think MLOps will be tomorrow is going to be building the applications and maintaining each AI application based on very flexible composition between standardized modules using standardized interfaces. And by doing this, MLOps will be very easy to upgrade by easily swapping out different components because they already communicate to each other based on the same interfaces. It's very easy to get an at-a-glance view of the end-to-end application to identify if anything is going wrong or if anything needs attention. There will be end-to-end automation that removes humans from the loop where humans are very inefficient at maintaining the end-to-end machine learning application, but still enables humans with expertise to have their expertise injected into the system where it really matters. And overall, also sets very well-defined boundaries between different people in the team that lets individual experts specialize in the roles that they really want to be in. And in the end, we end up with a picture of MLOps that's highly composable, automatic, and scalable to many different use cases and many more customers. So now we kind of get into our approach for tackling this problem, which is based on a full stack composability and extensibility of the MLOps problem. And by doing so, we want to flexibly compose diverse building blocks in standardized ways into new AI applications, or to recombine those building blocks within existing AI applications to very easily evolve and upgrade and to maintain them in deployment. So we, by full stack, we mean we are enabling composability and extensibility at several different layers. So first is at the data layer, right? So we enable composable interfaces for the data in the AI application. By doing so, improving the reusability of code modules between different related tasks, and also improve the collaboration between different experts in the team based on a fixed data contract that keeps the separations of concerns very well defined between team members. Second, we have composable interfaces for pipelines, and pipelines are essentially used to compose different processors, which are different pieces of code that have well-defined inputs and outputs, and to combine them into end-to-end tasks that deliver a specific outcome in the AI output. And the composable interfaces for pipelines also enable scaling an application from local development on your laptop to deployment on a cluster very seamlessly without rewriting a lot of the code. It also enables specialized execution systems for powering each processor, such as Spark, and such as many other systems that we've been working on that, for example, enable training to happen in distributed systems 300 or 400% faster and more cost effectively. And lastly, we have a layer on composable interfaces for infrastructure, which is meant to compose different subsystems into long-running infrastructures that support the end-to-end machine learning application, which enables an at-a-glance observability of the end-to-end application, as well as very simple and standardized way to manage and compose your infrastructure on a cluster. Okay, so just talking about each of these different parts one by one. So first, why standardize the interface for data, right? So one reason is that without a standardized interface for data, we suffer from very limited reusability of models and data processes across different machine learning and AI tasks. So, here's an example. Maybe we have a very simple pipeline consisting of 2 steps where we take some input from the user, process that data, hand off that processed data to do model inference, which delivers our output in the end. Now, the go-to way of doing this is by writing some custom glue code to tie these 2 processing steps together, which results in each of these steps being highly coupled with each other, thus limiting each of these modules' reusability in different tasks. But with a more standardized interface for data, we're able to completely decouple and modularize these 2 different steps for data processing, model inference, which makes it easy to reuse these different pieces of code for different tasks, or to recompose them in flexible ways within the same task in order to upgrade them once they're already in deployment. And another reason we want to composable interfaces for data is to improve the friction when collaborating within the team. So, taking this thin slice of the QA system that we presented earlier, with the complexity of these systems exploding in the real world, it's often the case that teams are having individual people working on individual pieces of the overall pipeline and then combining them in the end to form the end-to-end application. And a standardized interface for data enables a data contract between these teams as a point of agreement so that they can work very efficiently without incurring a lot of coordination costs in order to scale up the operations of the team. So in order to solve these problems, we introduce a composable interface for data, which is called a data pack. You can kind of think of the data pack as a data frame, such as from pandas or Spark, but it also very naturally supports unstructured data. It provides a standardized interface, a standardized format for data, metadata, annotations, and other attributes of data. Some examples here are, annotations on a piece of text, or the bounding boxes that would be associated with an image for object detection, right? So it's a very standardized format for expressing these attributes of either unstructured or structured data. And they are also organized in a hierarchical structure, which makes it very easy to define a processor on one particular attribute and reuse them in other applications as well. And we use our composable representation for data in our next layer, which is our composable representation for pipelines, right? So, just an example of different pipelines that are typical in machine learning. These days, you might have a inference pipeline that consists of several different steps to parse, clean the data before querying a model to deliver the final result. Or you might have a training or evaluation pipeline that runs in a batch setting on a cluster that trains a model and then performs inference on some validation or testing data and to evaluate that, that model according to certain metrics. And we introduce a standardized representation for these kind of pipelines, which is called a intermediate representation. And this representation is a standardized format that's expressed in a textual form, and it enables these different types of pipelines to come together and be expressed in a unified way and to be compiled and transformed in order to achieve downstream tasks. And a key design goal of our representation is to be able to decouple the abstract directed acyclic graph from the execution system, so it becomes very flexible to express different types of pipelines using a language that everyone's familiar with, like Python. And what this allows is that it allows separation of concerns between multiple people in the team. For example, a data scientist can very easily develop and test a pipeline locally on their laptops using Python, the IDEs that they want. This pipeline can get compiled and transformed into a format that can be very easily configured and deployed by an infrastructure engineer at the staging or production step without rewriting any of the code. It also lets our system automatically optimize the pipeline. So for example, we can automatically transform the graph to fuse processors for better latency in production. We can automatically parallelize different processors to achieve higher throughput for batch execution settings. And we're also able to jointly tune the hyperparameters between multiple steps in order to optimize for metrics such as the model accuracy. And in the end of the day, we can take our abstract representation and transform it into something that can be deployed in various different environments, right? So maybe you're working in maybe you're writing a training evaluation pipeline. We can very easily transform that into an Argo pipeline or Airflow pipeline that can all be managed using those systems and are very scalable in production. Or you might be working on an inference pipeline that is compiled down to a set of different Lambda functions on Amazon Web Services, which can then be deployed out in a very highly available and scalable way. So it's really, allowing everyone to express pipelines using a very simple language, testing it locally, as well as very seamlessly bringing it out into production in various scenarios like batch or online serving environments. And lastly, we have a composable representation for infrastructure, which is meant to tie together the different long-running services that are needed to support the end-to-end lifecycle of an AI application. So these are examples like, a continuously triggered retraining job, which outputs a model to a step where that model is evaluated and put into production. And maybe there's a different component that's exposing a user interface for data annotation where users can go to annotate data, right? So it supports all the long-running services across a end-to-end infrastructure for AI applications. And this representation makes it really easy to manage the end-to-end lifecycle, to configure it in a visual way, and also to see at a glance what the end-to-end infrastructure looks like in order to identify problems. And it also, fully supports both infrastructure as code, as well as graphical interface usages of this interface. So, a lot of engineers really prefer to, compose and edit their interface graphically, whereas other engineers really prefer to work with a configuration file where they can version and keep track of everything in a version controlled system. So it was very important for us to enable all of these different use cases. Okay, so just a quick summary before we get to our demo. One of the main goals that we're setting out to achieve is to enable full stack extensibility and composability, and we're doing so at 3 different layers. First, at the data layer, which enables better reusability and collaboration between teams working on different parts of the AI pipeline. Second is at the pipeline layer, which enables seamlessly taking code from development environments to production and enabling end-to-end automation. And third is the infrastructure layer, which enables end-to-end observability of your infrastructure at a glance, visual configurability, and governance of the whole infrastructure and application stack. All right, and with that, I want to hand it over to Tong, who will give a sneak peek at our closed beta version of our product.
Yep. Thank you, Aurick. Let me share my screen. Can you see my screen?
Yes, we see it, Tom.
All right, great. The goal of this demo is to show the significant productivity enabled by the Petuum approach Aurick just described. Our demo story starts with a data scientist. Her name is Erica. Erica is developing a language translator in her local dev environment. She chose to use a library with high level of abstractions. Forte is a toolkit with a pipeline framework for composing high-level NLP applications. In this example, you can see the translator can be expressed as a chain of NLP tasks. Now the translator is working. Erica wants to publish it so that more people can test it and use it. On Petuum Platform, this task can be done very easily with 2 simple steps. Firstly, Erica needs to insert the pipeline.export method into the Forte code that defines the pipeline, as shown here. The next step is to submit the pipeline onto a Petuum Platform cluster for deployment through a simple command line. Here, the noticeable arguments are the name of the pipeline, the code containing the pipeline definition, and also the target execution mode. In this case, it is HTTP serving. And we have to make sure the pipeline.export method is inserted. Now the submission process gets started. Under the hood, what's happening is that the pipeline logic is transformed into the Petuum IR format, and the code is packaged. Once you have an IR, it can be targeted at the different environment for execution. In this case, the target is Petuum's graph execution engine called Symphony. Now the submission process is completed. The deployment can be taken over by an MLOps engineer. His name is Eric. The deployed pipeline will show up, as you can see now, in the Symphony UI. Clicking on the project, you will see the visualization of the pipeline. As you can see, the pipeline is visualized as a linear graph. The graph nodes here corresponding to the NLP task as originally defined in the Forte pipeline code. Here we have the chunking reader, and more importantly, we have the translation model in the middle. For Eric to deploy the pipeline as a HTTP endpoint, he needs to further configure the Forte pipeline. Firstly, we need a name for the endpoint. For NLP tasks requiring additional computing resource, Aurick can modify the default configuration value. For example, the translation model, we want to run it on GPU instead of on CPU by default. We also want to specify the mount path for the model folder where the pipeline loads its model from. Once the pipeline is configured, it's ready for deployment. And you may also see the edges connecting the node in the graph, representing the data being transferred across the entire pipeline. The data on pipeline is in the data pack format Aurick just mentioned in his session. Now the pipeline is fully configured, is ready for deployment. You may have noticed that this is a no-code visual programming environment. To deploy the pipeline as a service, Aurick can achieve this goal with a very simple click-through experience. Now you can see the service is created. Now you have a URL for the endpoint so that any client code can use it to invoke the entire pipeline. Now Aurick starts the pipeline. While waiting for the endpoint get started, it's worth mentioning that given ONIR, a target execution environment, and also the corresponding execution mode, in this case, it is HTTP serving, Symfony can perform optimization to improve the performance. For example, in this case, Symfony tries to fuse all the building blocks together so that to reduce the data transfer cost between those building blocks, so to achieve low latency. Now the service is up and running. Erica can give it a try. In her test code on the client side, the code logs 3 parts, as you will see next. The first part is the input in English. The second part contains the response in Arabic. And also the third part indicates the version number being used by the pipeline. Since the deployment of the translator, the team has been trying to improve it. They want to automate the process to retrain the model and use the model to update the service. To deliver the same user experience Aurick and Erica has been enjoying, we bring composability down to the infrastructure layer. Symfony's Rampart platform support infrastructure as a graph. This is an example implementation to automate the process expressed as a Rampart graph. The graph nodes here are reusable infrastructure blocks instead of NLP tasks as Erica used before. The edges are called flows. Let me get back to the graph. The edges are called flows, representing the mechanism to transfer data between the building blocks. In this example graph, we have 4 blocks. The first one is the data uploader exposing an endpoint for remote data uploading. We have 2 batch executors. The first one executing the data preprocessing logic. The second one executing the retraining logic. We also have a generic service block, which expose a browser-based file browser for user to inspect the model folder. At the end, we have Symfony, the graph execution engine, where the HTTP endpoint is hosted. Now, another MLOps engineer, Kevin, can deploy this graph easily through a simple command line, as we will see next. Once the graph is deployed, it will show up in the run part GUI. Clicking, Kevin can open, now Kevin is opening the run part GUI. Clicking on the open button, it will show the infrastructure visualization as a run part graph. As you can see, each building block here has a status icon. Clicking on it will launch a Kubernetes dashboard for more detailed monitoring. Once all the status icons turn in green, it means the infrastructure is up and running. Now, Kevin trying to open the file browser to inspect the model folder content. As you can see, we have the base model, which is used by the original pipeline deployed. Now we have another checkpoint generated called version 2. Even after an infrastructure is deployed, Kevin can still modify it. For example, Kevin can change the data retention policy here. You can also add a TensorBoard block to monitor the retraining progress. The graph can be also exported as a YAML file. This YAML file is exactly the one Kevin used to deploy the infrastructure at the beginning. Now, everyone can trigger the retraining process by uploading a dataset to the data uploader endpoint. It can be a human agent or a software agent. This is an example to upload a dataset to the data uploader endpoint. Eventually, the retrainer will generate a newer version of the checkpoint and save it to the model folder, as we will see next. Then this screen shows the retrainer has completed. Please note that the retraining process is further accelerated by Petuum's AdaptDL technology. We have observed a factor of 3 speed up, so that the training time has been reduced from several days to less than a day. Now you just have seen a new version of the checkpoint has been generated called version 5. Invoking the endpoint will show that the model has been automatically updated. This is the end of my demo. Thank you, everyone. I will stop sharing.
Thank you, Tong. All right, yeah, hopefully that gives everyone a good sense of what our product looks like. So the next slides will just kind of close this talk. So what are some of the takeaways from what we talked about? So one, the ecosystem of machine learning AI tools is highly proliferous, but it's also very fragmented. And as users and as businesses who want to build machine learning applications, we want to take advantage of this ecosystem in a very flexible yet standardized way. What we've been building at Petuum is a unified set of representations at multiple layers of the machine learning stack. For example, for the data layer, the pipeline layer, as well as the infrastructure layer. And by doing so, we can enable better composability by enabling better modularity between different pieces of code. we can enable better automation as well as scalability. And in the end, what this all results in is more scalable and cost-effective ML ops. So, everything we've been working on is in active development. We also have several collaborations between Petuum and several academic institutions like CMU, Berkeley, Stanford, and MBC UAI. So just to close, the high-level vision at Petuum is to transform the production of AI machine learning applications from custom pieces of craftsmanship into standardized, repeatable, and scalable processes. And with that, our product is also entering the closed beta program. So if anything that you saw appeals to you, please drop us a note. We're currently accepting applications to trial our product. And thanks. And we're happy to take any questions at this time.
Thank you. You can go ahead, Adil.
Oh no, I just want to say thanks. That was really excellent. Good to see some questions as well from the team. We'll give people some time and the attendees to frame any additional questions that you all may have. I have one to get us started, which is around the connections and integrations to other tools. In particular, how can we connect Snowflake or Spark to the system for use in our models? So I guess this is a question for Aurick.
Well, yeah, thanks, Adil, and that's a great question. So I think one of the biggest benefits of having this abstraction that's very composable is that it's very intuitive and easy to see that, when each of these components are reusable, we can build up a library of such processors and connections, right? Including, for example, a reusable processor for reading from Snowflake, right?
Okay. All right, thanks.
We have another one from the chat. Just
go.
a quick question. How can we keep track of models and artifacts?
Oh, yeah, that's also a great question. So with the infrastructure layer that we showed, we have different types of flows. So one of these examples is a versioned repository flow, where two different components of the infrastructure can actually send versioned artifacts to each other. So it's a very intuitive way to manage the versioning of different artifacts between different pieces of the infrastructure.
So if I understand correctly, Aurick, what you're saying is that versioning in a way that MLEs probably are pretty accustomed to is exactly the way that you would do it with the Petuum platform. Okay, I hope that's a good answer. There's another question in the chat about a toy product. I believe the question is a very kind of succinct question. I believe the question here is this a toy product, or are we at a stage where we're ready to bring it to customers? Yeah, Aurick, would you like to answer that?
Yeah, that's a great question. So our product is not at this current stage of being 100% production ready. So we are in a closed beta phase where we are approaching clients and customers to work very closely with them in order to really scale up their operations in the long run. And that will include working through some of the edge cases and corner cases of getting the initial versions of the product to run smoothly, right?
Great. And I might add to that, the products that we are currently bringing in the private beta, it has been through quite a lot of iteration. With our current customers that it's being deployed at, it's fully deployed in a large on-prem setting. That doesn't mean it's not deployed on the cloud. In fact, I believe it is being deployed on-prem as well as on cloud. So it's been through quite a few iterations. I'd say that the private beta is an example of the kind of engagement that we really want to have with people, which is heavily collaborative, so that we can build into that feedback that we would be getting. Yeah.
Okay, let's take another question. Let's see. How is this differentiated from other tools in MLOps like weights and biases or AWS SageMaker?
Yeah, that's also a great question. So, if we look at the ecosystem of tools in the MLOps space, there's quite a lot of different players, right, in the graphic that I showed in the second slide of this talk. So many times you'll find that products are very strong in certain aspects of the whole MLOps picture, right? And there's really no one-size-fits-all solution. And what we're really trying to enable people to do is to pick the best pieces of each step of the way, right? And enable companies to tie them together in a way that works for them, rather than being locked into one single end-to-end solution from end to end, which are invariably going to have areas of those products that are not going to be serving some of the unique aspects of each AI application to the best of their ability, right?
I might add to that, Aurick, that we've seen in the case of specifically AWS SageMaker and other hyperscalers as well, there's a trend, as you mentioned, of being within that ecosystem, but then also that within that ecosystem, you might not find that one very strong feature that has these types of intermediate representations or integrations, although that might be a goal that they have. I don't believe that anyone out there has developed this kind of composable system for infrastructure data and pipelines that we've seen. And on the flip side of this, by the way, there are companies like Weights and Bias, all great products, right? They are very good in their very specific domain. I believe Weights and Biases has a focus more on the experimentation part of the MLOps ecosystem. And if you refer back to that image that we had shown earlier of what is MLOps, usually when you see a tool, you can align it to one specific area. In our case, we are aligning to as many areas as possible with definitely an infrastructure focus and on the data and on the pipelines. But of course, as Aurick mentioned, one really important differentiator that I find is that it's very easy to integrate additional products into the system.
Great. We have another good question. What are the factors that cause the training time to go down by a factor of 3?
Yeah, so it's really from the algorithms that we're using to tune each training job. So what we found working with several companies who are especially working on deep learning models is that oftentimes the basic hyperparameters and configurations like batch sizes and learning rates that you would get from using defaults from a GitHub repository or from a paper are actually very not well optimized for the particular settings that they're trying to apply it in, right? And just by automatically tweaking those parameters, we're able to discover configurations that are much, much more efficient for the specific cases that those customers are applying their models in.
Okay, we have another question maybe for you, Adil. I think it's in reference either to the private beta or to our future plans. Will this be on-prem or SaaS?
Oh, I think I got into that a little bit in one of the earlier questions. Yeah, I guess the best way to think about this is deploy anywhere where Kubernetes is, right? Kubernetes could be anywhere. And so, yeah, as I mentioned, we are currently working with a customer to have a large on-prem deployment as well as on cloud. And we're going to work to SaaSifying as much as possible because we believe in being able to use the software as wherever you are. Yeah, Aurick, would you add anything to that?
Oh, I guess the only thing I'll add is that our product is able to be deployed in various different environments. So that includes on premises and as a service in the cloud. For example, if you're running in AWS, we can make it very easy to deploy the platform from the AWS marketplace, or similarly on Google's cloud or Microsoft Azure. Anywhere you can run Kubernetes, you can run the platform that we've been building.
Okay, one more question from the chat. Is there an estimated ROI for time, hours, etc. that Petuum provides to a customer? How does Petuum's beta product ROI compare to competitors?
Ooh, that's a big question. I'd love to answer this in the detail that the asker is asking for. I'll kind of start with just saying that a major reason for the private beta is to get some good benchmark data on all of this, right? So we have some estimates, right, especially based on the research that's been done on the ROI. Training time, for example, can easily be converted into compute-based ROI from cloud instances, or depreciation-based ROI from on-prem, right? I feel like the biggest savings comes from the amount of time that an individual spends. And in this case, we covered a couple of different roles. I think we had Eric and Erica. We had people that are focused more on data science, people that are focused on pipelines and machine learning engineer overall. Some people that are Kubernetes experts that are focused on infrastructure, and a team leader who might be involved in managing all of the systems and user management as well. So there's a number of different roles that are all having significant chunks of time chopped off from their work, thanks to the composability and the management. So I would say that there's a clear ROI that comes from the human productivity, and there's another clear ROI that comes from the compute productivity. And we have some metrics on that, of course, but we want to benchmark all of those over the next several months with our private beta users. And with that in mind, if you're interested, in helping us to get those benchmarks with respect to competitors, that would be awesome. And that's exactly what we're looking for. And people that have tried things out in the market and want to see if our solution is actually going to generate a lot more ROI in the near term and the long term.
Yep, I would like to echo what Adil said about there's kind of two sides to the ROI that we're optimizing for, right? Like one is more on the human productivity side, and the other is on the compute productivity and cost reduction side, right? So, on the compute side, we already have hard metrics and numbers for those from our many research papers on cluster resource scheduling and distributed training optimizations and all of that. So you can actually find those on those papers on our website. What we're trying to get to with the private beta, as Adil mentioned, is to be able to better benchmark these other metrics on the human productivity side more effectively and more accurately, right?
All right, I think that's all the questions that we had collected before the webinar and also all the live questions that we've gotten. Would love to, if anyone has more questions, we have 2 minutes remaining. We'll just give you some time to type out anything, any burning thoughts that you might have. Also, by the way, feel free to just comment right on the chat or in the Q&A about how you think things went, what you're interested in trying out, what parts of this stuff might not be as interesting, what parts might be really exciting and make a difference to MLOps for your team. We'll pause there then. By the way, do ask questions. Here's one thing to keep in mind. We are, we're open for our private beta, as I mentioned. We are trying to be very selective with the companies that we bring on to the private beta. So if you are going to get in touch with us, please leave a little bit of a description of the use case so we know whether to reach out to you. We'll, of course, always respond regardless. Do email us and check out our website at petuum.com and to find out more about the things that we've been doing. I also want to repeat the idea that if you are interested in working with us, we are a growing team and we could probably find a good place for you if you're interested. So just give us a shout. I think we can, if you've left your email with us, we will reach out to you regardless to find out how things went, because it's very important to have feedback on these things. I think with that, we're at the end of our time, Julie. What do you think?
I think that's about it. We did have one more question in the chat, and it was just about if you're interested in our beta product, what can you do to get in touch with us? So that marketing@petuum.com email address is a great place to go. And if you visit us at petuum.com, there's a form to fill out to apply. So we'd love to hear from you. And also check us out tomorrow at ODSC. We'll be giving another presentation at 4:50 Eastern time.
That's right. Yeah, that's right. If you're going to ODSC, then please see us. If you're not going to ODSC, hit us up. We can get you access so that you can see our presentation.
Okay, thank you everyone for coming by, and we'll be in touch if you have any questions.
Thank you, folks.
Bye.